And if anybody has just come in within the last couple of minutes, I admitted, what we're going to do is we're going to be practicing today a little bit more on the variance and the standard deviation. And that's because the formulas get pretty complex, and it's really important to understand in our MAT150 class what we're doing to get those formulas to work. And once we have like variance equals 5 or standard deviation equals 4, we really want to have a good understanding of what those numbers mean. And that's because when we go into later formulas in chapter 3 and 6 and 7 and 8, we're going to end up using the variance and standard deviation for almost everything. And we really want to be able to know what's happening, because when stuff goes wrong in the formulas or when we have to do interpretation, we want to be able to move along quickly and analyze the situation as efficiently as we can. And we don't want to spend a lot of time looking things up. So what I'm going to do is turn over the screen. And all you're going to see is a big green, a big purple square. Okay, so our first question is going to go out to Talia. That's number 1. So we're going to do a couple exercises, review on variance, review on standard deviation, and then we'll actually get into some computations, and we'll make sure, like, if this was the test and we had to calculate out a variance right now, would we be able to get it right? So Talia, the question is saying a variance is a measure of central tendency, true or false? What do you think?
True.
All right, she's saying true. So everybody, on count of 3, blurt out if you think it's true or false. We're going to find out if Talia's right. 1, 2, 3.
True.
False.
It looks like about half the people are saying true, half the people are saying false. The fast answer is it is false. Why is it false? What are central tendency? And I have to see if I can get that person admitted in. What are measures for central tendency? That was in section 3-1. Those were things like the mean, the median, and the mode. So the next question goes to Natalie. That's number 2. Natalie, this one's yours.
True.
Okay, that one is true. And I need to move the chat window out of here because now it's blocking my view. Here we go. Okay, you're exactly correct. Dispersion has to do with how spread out those numbers are. If your variance is really high, it means your numbers are very separated from each other. There's going to be going up and down in leaps and bounds from one value to the next. And that brings us to Zachary, number 3. Zachary, this one's for you.
You're loud as hell, man.
Say again, Zachary?
I know what you're talking about with me.
I can hardly hear you. What do we think, everyone? True or false?
False.
Okay.
False.
Some trues and getting some falses. And the answer is going to be a false. What's making it a false statement?
The squared.
Exactly correct. That's what it is. What happens is if you said true, you fell into the trap. And it says square distance. What measures the average square distance you are from the mean?
Variance.
Exactly correct, yeah. And the reason we got to the standard deviation to begin with was the variance measures the average square distance a number is from the mean. And we say, okay, that's really great, wonderful, but we don't walk around talking in terms of average squared anything. So we say, okay, let's say average distance we are from the mean. More people will understand that. And we have to do something to remove the square. That's what the standard deviation does. It kind of rolls into town and it says we're going to use a square root and we're going to get something that everybody could understand a little more easily. So that's our difference. Whoops. That's our difference between the standard deviation and the variance. Everybody okay with the first 3 questions?
Mm-hmm.
Okay, so we'll go into the next
Yeah.
section here. I'm going to bring it through. And this is going to go to Amanda, number 4, as soon as we roll it past. So now we're going to talk a little bit about symbols, because you guys are going to need to know symbols for the test. I'll probably ask you about 8 questions that are just going to be matching symbol to the definition.
C.
Okay, so Amanda's going for C. Amanda's picking C. What do we think, everyone? Is Amanda thumbs up or thumbs down?
Thumbs
Thumbs
down.
down.
Okay.
Thumbs down.
What do we need to make it thumbs up? What would be the modification on C?
Getting rid of the squared.
Excellent. Okay. Right, you guys, you got it all correct. Yes. We have to remember that, okay, the standard deviation is going to be equal to the square root of S squared, because S squared stands for the variance. So the right symbol would be S. And make sure that you're maintaining that list of symbols in your index of your notes that we talked about, because that's going to help you with literally 7 questions easily, just by knowing that one sheet and having it in a place where you can find it. Questions on anything so far? Okay, so next one. And I think we're down to, let's see. We just heard from Amanda. This goes to Deanna, number 5. So Deanna, you have a really interesting one. You get the drunk question. Deanna, what do you think?
I need 1 second.
Okay, take 2. What are some things that Deanna can think about that help her determine which one of them is drunk?
Is it the first one?
Boom, you're right. How did you know?
I don't know.
So yes.
Yeah, it seemed too big of a number.
Okay, well, your instinct was right. You should be like a professional guesser. Okay, what's happening, that standard deviation is trying to tell you how far your numbers are from the average. So if we went and looked at what Kramer said, 2.5, we look at the data set, and what would you suppose the average was, Deanna, if you were just gonna like take a shot in the dark at what the average might be, like on the fly? And just say the first thing that comes to your mind. Don't try to like mentally calculate or anything like that. What does it look like it wants to be?
20? It's like 3 point something.
Okay, yeah, very nice. Well done.
No.
So around 3-ish, perfect. So we would say most of the numbers are pretty close to 3, right? We're not really getting far away from 3 there.
Yeah.
Well, Kramer looks like he's on the ball. I'm saying he. I'm thinking of Seinfeld. That's where I got Kramer from. Anyway, Kramer is saying most of your numbers are within 2.5. And would that make sense to us? Would we find it believable? Probably think, yeah, we're going to go with that. Now, Bruce Wayne, do we have numbers as far as 50 away from the average? Now, see, a lot of people shaking their heads, and you guys are correct. We'd say that Bruce Wayne probably had some like case of beer or something before he came up and said that. Okay, and I think Moshe is next. Moshe, this one's yours. Which data set looks like it has the highest variance?
Highest variance?
Yeah, like the top one, the bottom one, or the middle one?
The middle one?
You are right. How did you know?
Has a bigger difference between the values.
Perfect. Good instincts. It's going up and down in leaps and bounds, so it probably has the highest variance. Okay, and this is going to bring us to number 7. That's Jaleesa. Oops. here it is. What do we think, Jaleesa? This one's going to make you think a little bit. Jaleesa, can you hear us? Jaleesa might not be plugged in with the audio. I'll come back to Jaleesa. I'm going to go to number 8, Roberto.
Can you hear me?
Very well.
Okay. I'd say true.
All right, Roberto's saying true. What do we all think, everyone? If you want to even shout it out or just write in the text window, right? The text window, I think they call it a chat window. If you think it's true or false, let's see what the vote is.
False.
Okay, I heard a vote for false.
I think it's true.
Like 6 falses.
False.
Okay. The falses win. What makes it false? Well, the variance we start off with, then we get the standard deviation from the variance. One's the square root of the other. So if we're saying, for example, like we start with a variance of 16, the square root of 16 would be 4. If that 16 goes higher, is the square root of that number going to get bigger or smaller?
It'll get
Yes, yes it will. Well done. So whatever the variance does, if it gets bigger, the standard deviation is going to get bigger. If the variance gets smaller, the standard deviation is going to get smaller. So it can't move in opposite directions. The variance and the standard deviation will have to move together. And sometimes that does come up on the test. There's going to be a few true-false questions. And oh my gosh, professor, what are the questions going to look like? This will give you a really good example of the types of things that they're going to be asking. Anybody have any questions before we keep moving? Okay, I'm going to go into the next one here. And this is down to Aram, number 9. So it's Aram, it's saying the averages of all the data sets below are right around 20. Which one do you think is going to have the highest variance, and which one do we think will have the lowest variance?
I think the highest will be the top one.
Okay, so she's saying the highest is on the top. What do we think, everyone?
The highest is the middle.
I heard somebody say the highest is in the middle.
The bottom.
Yeah, I think it's the
last
middle.
one.
I think it's the last one.
The correct one is the last one.
Ooh.
The best way to figure it out really quick, you see how the bottom one has a 0 in it? And then it also has a 35 in it? That means it's really going up and down by leaps and bounds. So when the variance gets higher, it means that each number is further away from the next number. And we see a lot of that. We're going from 10 down to 0, then jumping all the way up to 35, going down to 20. And if we look in another data set, like the top one, it's very, very stable. It's hardly moving. So the one on the top would have the lowest variance.
So as a general rule of thumb, could we say that if the range is higher, then the variance is going to be higher? And if the range is lower, then the variance will be lower, or will that not work?
That's a very good question, and it's only going to work about half the time. And the reason why is because the variance can't see the numbers on the inside of the data set. I'm sorry, the range can't see the numbers on the inside of the data set. It can only see the endpoints. So if you had a data set that looked like 1, 2, 3, 4, 5, and then 800, you're going to get this really crazy number for the range. And it's going to kind of blind you from what's actually happening in the data set. So the range will be really high, but the variance is going to sharply contradict it.
Mm-hmm.
Now, the good news is I'm not really going to ask you anything about range at all. So if that helps a little in terms of trying to like compare the two. Anybody else have any other questions? I'm just going to pause a second. We're gonna,
So sorry.
go ahead.
So the lowest variance will be the top one instead.
Yes, it will. The lowest variance will be the top.
Okay, thank you.
You're welcome. I'm going to check our chat window and make sure we're clear down here. Okay, somebody sent me a message about a technical issue. All right, let's go ahead. Let's push into the next one. And we're up to Lauren, which is number 10. Let's roll the screen. Okay, well, actually, we won't make just Lauren do all this work because that would be a lot for her. So the last thing that we're going to do before we get into some new concepts is we're going to take a data set, and I tried to keep it really small. What I want you guys to do is take a few minutes, calculate out the variance, and see if you can do it without looking at anything. We're going to see how we do. I'm going to put, let's see, about 3 minutes on the clock. If you have any questions, go ahead and shout them right out. Somebody else probably has the same question. Turn on the timer because I'll forget right after if I don't. There's about a minute left. And does anybody feel like they could use another 5 minutes? Or just another minute?
I could use another minute.
Sure. Okay. Just want to see where everybody was. And we'll do about another 30 seconds, then we'll stop. And I'm gonna see if I can get somebody in here that's trying to get into our video session. Okay, did anybody get it?
It's 44.25.
I heard 44.25. That is exactly correct. Now, just so you know, people are going to be doing strange things with rounding, different things. Like some people are going to round to the 10th digit. Some people are going to round to the 100th digit. So if you got pretty close to 44.25, like maybe up to 47 or down to 40, you probably did everything right. On the exam, I never look for like exactly the correct number because nobody's going to get it. Like you're very, very rarely going to match the answer in the back of the book, but you'll get very close to it. Something else that's probably worth mentioning. Do I have anybody that's taken a physics class or a chemistry class? Okay, see people nodding. How much fun were significant figures? Now I see people getting really mad. I know the feeling. I've done a couple of those classes too. So great news. We don't do significant figures here in this class. We're not going to worry about rounding like to that degree of precision. So if you were worried about that, you're going to be really happy here. So let's talk conceptually about what we're going to set up for. When we look at the data set, we're going to end up needing an average at some point or other. If you had to approximate the average just looking at that, what would you think the average was?
Around 50, 40-ish, 45.
You mean like the average of the data set about 40?
Yeah.
Any other guesses? What else do we think? Is anybody getting the same or something different?
Say like around 13.
Okay, maybe around 13-ish.
No, that's not right at all.
So if I came in and I told you guys that the variance, or even better, the standard deviation was 85, would you think I showed up for work drunk?
Yes.
Yeah, you could say yes.
Yeah.
So the reason why we mention that is because if the standard deviation looks like it might be around, I'm guessing here, maybe a 4, I know the square of 4 is 16, so it's really going to help us take a look at the answer and see if it makes sense when we get there. Okay, so take a little bit of a walk through. What we could do is we could put in our same columns before. And what I like to do is start off with my x's. I'm just going to vertically put them in a row. And then I know that I have to subtract the x from the x bar, because my variance formula is going to say I need the average square distance each number is from the mean. So I'm going to put in my averages. I'm going to subtract each number from the average. Everybody okay up to here so far? Anybody not sure how we got anything? Okay, I'm going to square all of those numbers. And then what do I have to do with that last column?
Get the sum.
Yeah, I have to get the sum. So my sum is going to be, I did with this with all the decimals, 132.75. Now, when I bring it up and I start to do the division, I've got to move some dashboard items out of the way here. Okay, I probably should have had that formula up from the start. I'm going to take the 132.75 and I'm going to divide it by 1 less than the total number. I'm going to get 33.1875. Any questions on how we got there?
Professor, where did you get 11.25 from?
Let's see. The 11.25 was the average I got for all the 4 numbers there.
Mm-hmm.
Okay.
I'm actually really glad you asked that. That's going to bring us straight into something very important.
I have a question.
Sure.
It says 5 minus 1. Wouldn't it be 4 minus 1?
Let's see. Where are you looking?
When you divide 132.75.
Oh, you're exactly correct. Yes. That should be 4 minus 1. Let me hop in there and do an edit. Thank you. And It's funny. This is where I see your picture, but it doesn't have a name on it. What's your first name?
Victoria. Bless.
Gloria?
Yeah.
Okay. Gloria, I like your shirt. Tu estás muy
Victoria.
buena. Victoria.
Yeah.
Let's change that to a 4. And this probably means that number you guys gave me before. I think you said variance was about 44.25. That's what I heard when you shouted out your answers. So I'm going to change this.
I also have a question.
Sure.
Wouldn't 3 minus 11.25 be negative 8.25?
Oh, yes, this is correct. See what? I'm going to check my my edit screen on my calculator, see if anything strange, any other stuff strange happened here. This is an 8.25. Okay, I think I just botched that on a keystroke. The 8 squared would be around a 68.063. Thank you for mentioning that. I want to fix that for everybody.
You're welcome.
Okay. Any questions on how we got to that 44.25? Everybody feel like if you were on the test, you would be able to repeat all this?
Yes.
Okay. Now, something that's really important is somebody was asking us about the average when we started. When you're doing the variance, you kind of need the average to kick off the whole entire thing. And without it, you can't finish it. So statisticians didn't like that. And they took the variance formula, this one right here that I'm moving around, and they rewrote that whole entire thing because they wanted to find a way that you could calculate variance without having to take each number and subtracting it from the average. And they came up with, in the book, what they call a shortcut formula. And I'm just going to mention it very, very briefly. Let me see if I can give you the page number. It's on 129. Now, usually I don't teach the shortcut formula because they call it the shortcut formula, but it's really hideous. And it's a lot of memorization. I'm not even going to put it on the screen. I just mentioned to people, if you want to use that on the exam, you can. But it requires so much memorization because there's many more symbols in it. And if you look at the formula, it doesn't really help understand the idea that you're taking the distances between each number and the average and arriving at the average distance. Or said more efficiently, we're taking each number, subtracting it from the mean, and then getting the average of those distances. And a shortcut formula doesn't really help you understand that. It's a whole bunch of symbols, and if you forget one of the symbols, you're pretty much sunk. You won't be able to solve it. So if you want to use that formula on page 129, you can. It's there for you if you want to look at it as a reference. It's completely valid on the test. Something else that the book is going to do that I will not ask you on the exam, they're going to mention something called the variance and standard deviation for group data. And what they're trying to teach you is how to go back to a frequency distribution and calculate the variance off of that. I'm not going to ask you anything about that. We're not even going to talk about it. And it's crossed out in the PDF. So even if you're thinking like, oh my gosh, he's going to ask me that on the test, not at all. It takes like 25 minutes to calculate it out, and it's not going to help us with anything moving forward. Anybody have any questions on anything before we start to move into our next topic here?
I have a quick question, Professor.
Sure.
What if I accidentally rounded that 44.25 number?
Well, that's a very good question. You mean like to 44?
Right. Like, what if I just rounded it to 44? Would that matter versus?
Not at all. Not at all.
Versus doing the division and then rounding that number or whatever?
No, no. In fact, that's a great question also. And usually what I'll do on the exam is I'll give you guys a rounding instruction. Like I'll say you can round to the nearest tenth digit or you can round to the nearest whole number. And then when you're comparing answers between each other, because I know you guys are probably going to be comparing homework and test stuff too, especially on the homework, it'll make sure that you're getting answers that are aligned with each other. Does that help you? I mean, does that answer your question?
Yeah, that's perfect. I just,
I know it freaks people out. They're like, oh my God, I got 38.2. Is this okay? Or did I just lose all the points?
right. So thank you for explaining that.
You're welcome. Any other questions?
When we're going over like the answers on our own in the textbook, is that shortcut formula the one that's in the answers? So like the answer sheet,
and your answer will come out identical if you use the shortcut formula.
I just want to, that is the formula though, that's in the answer sheet, like it's like n change in x squared minus.
I know exactly the one you're speaking about. And that's the fast answer is when they did the solution book, I think they used a computer program to get all the answers. So they didn't use either of them. They used a program that could probably do all the calculations in about 2 seconds in the end of the book.
Okay. So that's a different formula from both of them?
Oh, well, that's a good follow-up point. It would be the same formula. It's just that when they program it into, like if you were to do this in Excel, it would do the calculation in the blink of an eye, but you would never be able to figure out which formula that it had been programmed with.
Okay.
That's a great question. Because sometimes we practice this stuff on Excel. We're saying, okay, I know how to do it. I just want to make sure I get the answer right. And let me just use Excel to help me a little bit. Any other questions?
So what is the rule about decimal places? Is there a rule? I just can't remember.
They do have a rule in the book. I think they're going to tell you to go to one more digit than you see in the data. So if your data is whole numbers, they're going to tell you to go to the nearest tenth. If your data goes to the hundredths digit, it's going to have you go to the thousandths digit. To make things easier for us, we're probably not going to get to that level of detail with it because you're going to spend 80% of your time chasing rounding errors and you're going to really lose the concept behind what we're doing instead. So on the exam, I'll probably say you can round everything to the tenth digit. And there'll be more of a directive so that you don't have to worry, like, am I doing everything right with rounding?
Okay.
Any other questions? Okay, so let's go ahead and let's roll into the next topic then. The next thing that we're going to talk about is when we were doing the variance formula, what's the one thing that we haven't spoken about yet of all these different pieces of the formula? Why did we have to keep on doing this n-1 thing? So let's take a minute to talk about what that was all about. And I'm gonna go into the next screen, just like so. Here's what happened. When we were doing our formulas, so far we've only been using the formula for sample variance and sample standard deviation, and we didn't know it yet. Now, if we wanted to calculate out population variance and population standard deviation, technically we would never really be able to do it because we're not going to have data on every single member of the population most of the time. So what we do is we rely on the sample standard deviation, the sample variance instead. And there's this little problem that comes up that we haven't talked about yet when you're doing the samples. And basically what happens is your sample variance is going to be way off the mark from the true population variance. And that's bad because it means we're using the sample to estimate stuff and our numbers are off. So you put a fudge factor into the formula to fix that. And the fudge factor is the n-1. Now, the bad news and the good news. The bad news is that these are the other formulas for population variance and population standard deviation. The good news is I'm never going to ask you to calculate population variance. I'll never ask you to calculate population standard deviation. The only calculations that you'll have to do would be sample variance and sample standard deviation. What you do have to know though is the symbol for the population variance is sigma squared. That's that funny looking thing that kind of looks like it's a whistle or like a number 6 pushed over. You need to know the symbol for the standard deviation of the population also. We call that sigma. And I see there's a landscaper right under my window now. I think that person will be going in about a minute, but I'm sorry about the noise coming in. Make sure that you are able to go to your note sheet and put in those two symbols, the sigma squared and the sigma. They're going to show up all over the place in the book and in the homework and exercises on the tests. They're going to be, they'll set up a problem and they'll say sigma equals 5 or sigma squared is 25. And we have to know how to put those in other formulas. Questions on anything? Okay, so what we're going to do is we're going to take a look at why we have to put that fudge factor in. And don't worry, there's no math in it. There's no calculations. There's no numbers. We're just going to do it with a really easy to see graphical example. Who likes money? Okay, that's what I thought. Lots of people. So we're going to do a money example. And what we're going to do is we're going to be taking a look at population of people out there making part-time wages. And just so you know, on the exam, I'm not going to ask you why do we have to do n-1 when we're calculating these things. This is just so you understand the computations a little bit more. So just kind of put your feet back and relax, enjoy a little bit. So the number line up at the top is saying we're looking at a population of wages that part-time people earned. And we go all the way from, I guess, $8 an hour to somebody up there making $500 an hour part-time. And that might be somebody that's a lawyer, or maybe they're a psychologist, they're billing by the hour or something like that, and they only work part-time. Now, what's important is the variability is really spread out. We're going between 8 and 500, so that's an extremely variable data set. As the graph that we see on the bottom that says sample of wages earned by part-timers, does it appear more variable or less variable than the data set on the top? And I think we're at, say again?
Less.
Yeah, you're exactly correct. So in the sample, what they did, they took 1, 2, 3, 4, 6 people, a sample of 6 out of the population. And when they did that, they just have a small bunch of numbers. It's not nearly as spread out as the population data because we don't have everybody that we have in the population. So our variance is going to be much smaller when we look in the sample. So do we think that's good or bad? Lauren is number 10. Lauren is next. Lauren, if we know the sample variance is much smaller than the population variance, would that be a good situation or the bad situation?
Would it be bad because it wouldn't necessarily be accurate to...
Exactly correct. Yeah, it's not accurate. It means you're sitting there trying to approximate stuff about the population and your numbers are way off. That's really bad. So we know that we're going to be, excuse me, we know that we're going to be underestimating the population variance. So that means we have to fix things somehow. Like we got to take the sample variance and do something to it to make it look more correct. So do we want to take the sample variance and make it bigger or make it smaller to fix the problem? I'm going to ask that to Isabel. She's number 11. She's next. Isabel, would we want to fix it by making the sample variance larger or smaller?
I would say larger.
Exactly right. Yes. We want to inflate it. So how do we inflate it? What we're going to do is take that formula for the sample and we're going to shrink the denominator. We're going to shrink it exactly by a factor of 1, because if we have a fraction and we shrink the denominator, it's going to make the whole quotient larger. And that's exactly what we need because our standard deviation is way too small right now. So we want to find a way to blow up that sample standard deviation, the sample variance. And that's why we've got the n-1 in there. And if that seemed like a whole lot to understand, don't worry, it's a lot to observe. You're right, it is a lot to figure out all at the same time.
The n-1 is to make it bigger only in this example, right?
Every time you calculate it out, it's going to make it larger, which is what we want.
Okay.
Because that's that thing where over here, the sample variance is always going to be smaller than the population variance, and we need the two of them to be much more close. Because usually we're going to work with samples, and we want our sample to be as accurate as we can get it when we run calculations on it. Any other questions?
Sorry, can you say that again? You said the sample is always going to be smaller?
Yeah. The sample variance will always be smaller than the population variance. And we can see that on the graph here, because you see how the numbers look like they're a much tighter window than when we look at the population variance.
Okay, thank you.
You see that on the visual when you're looking at the top and the bottom. And I'm not sure if you can still hear me, because it looks like your audio just went out.
Oh, no, yeah, I can hear you. I said thank you. I was just writing this down, and my dogs are barking, so that's why I muted it.
Okay, so because the sample variance will be always less than the population variance, that's why we're adding in that inflation factor, so we can fudge the number back to where it needs to be, closer to the true variance.
Okay, got it. Thank you.
All right. Any other questions?
Can I just ask, sorry, like what are you increasing?
Oh, okay. All we're doing is when we drop the denominator down, it's going to make the whole entire variance larger. Like if you think about it, let me see if I can drop in a text of this right on the screen. I'm going to take a fraction that's 1/4, and I'm going to make another one, actually, over here, that's 1/3. So in which case is the denominator smaller, the left or the right?
The right? Oh,
yeah.
Oh. Yeah.
You're exactly right. Now, which is a bigger number though? The one on the left or the one on the right?
The left.
The right one is going to be the bigger one.
Oh, the whole number?
Yeah. If you think about it, like if you ate 1/3 of a pizza or 1/4 of pizza, and you were really hungry when you opened that pizza, would you be hungrier at the end if you had 1/4 of the pizza or 1/3 of the pizza?
1/4.
Exactly correct. That's it. So what that means is if we shrink the denominator, we're going to make the whole number, the fraction itself, larger. If we increase the denominator, we're getting less pizza. So smaller denominator, less pizza. I'm sorry, I said that backwards.
I can't really understand things conceptually through math, but if you like go back to the last slide with the population versus sample, what are you increasing there in the sample? The range of numbers?
Great question. The only thing that this told us was that when we look at the sample variance, you see how the window of the numbers on the sample is much smaller than the number range of the population? Like when we look at the sample.
Yeah, so it's going from 15 to 56 instead of.
Right.
Okay.
So that actually means that the variability is going to be less in the sample than in the population. Like if the variance of the population was 200, the variance of the sample might only be 10. And we would say, well, that's terrible, because it means that we're going to get a sample variance of 10, and it's not even going to be anywhere close to the true variance. Does that part make sense so far?
Mm-hmm.
Okay, so if the sample variance is coming in so small, we want to do something to make it larger, to inflate it so it's closer to the true number. And that's why over here, we're taking the sample variance and we're making the denominator much smaller, because if we make the denominator smaller, like down here, the 1/3 has a smaller denominator, and the 1/3 of a pizza would be a much bigger pizza than a 1/4 pizza. So when we get to the fraction end, all you have to remember is smaller denominator means bigger fraction. Would it help if I wrote that in?
No, I got that.
Okay. Does that make more sense, or how are we doing?
So Professor, you're basically trying to get them on like equal footing?
Yes. Yeah, you're trying to get them on equal footing. And the reason is we're using the sample to tell us about the population. So if we have crappy calculations coming out of the sample, we need to do something to make them closer, more on equal footing with what the true variance would be.
Okay, I know this is a dumb question.
Probably not. I bet everybody else has the same question.
If we're already doing like imagine we're like economists or whatever, right? And we're compiling information on the population.
Sure.
Why don't we compare the sample to the population if we already, you know what I mean? Like if we're talking about people's salary.
That's a really great brainstorm.
Yeah, why take out the sample?
All right, that's a really smart comment. And the answer is, if you're talking about something like the census, you're really lucky. You've got data on everybody. But if you wanted to know something like, let's say, who's your favorite actor or actress?
That's hard to say. I mean, but I guess for purposes of this, let's say like Matthew McConaughey.
Okay, so great choice. So Matthew, let's say he's on the air and he says maybe he comes on the air drunk or something and he says a really off-color remark. And then the next day, everybody's saying, oh my gosh, all the ratings are going down or public opinion is getting worse. And somebody wants to figure out what's public opinion doing? Just like when a government official or somebody is running for election might do the same thing. So in that instance, they're not going to have data on the whole population. They're only going to have enough time to draw a sample. And they're going to have to try to estimate based on what they see in the sample.
Okay.
Like, I guess even closer to home example, if Joe Biden were to make a remark that just goes over very poorly, and his campaign manager says, oh my gosh, we need to know what just happened to your approval rating. This could cost you the election. Would they have enough time to go and get data on every single member of what the population thinks of Joe Biden now? And we would say, well, no, there's 300 million people. They couldn't possibly question everybody overnight. So instead, they'll do a sample from the population, and then they'll be able to generalize based on the sample.
Okay.
Does that make sense?
Yeah. So you're saying, like, if we were to compare like data from the census to data from the IRS, like about people's incomes.
Yeah.
So the sample would probably be the census that's voluntary that everyone fills out.
Right.
But the population would be probably the data that comes from the IRS.
And if you took all that data from the IRS, you calculated out the, let's say the population variance of income, and you compared that to a sample of people, and you didn't use that N-1, you just made it N, you'd have a huge discrepancy between the two numbers.
Right. Okay.
That's what it's trying to fix.
Right. Okay. And so then this is just a way to get them on equal footing by comparing.
Yeah. And I'm not going to ask you on the exam why we do N-1 and, what's that trying to correct. We're going to end up using the sample formula a lot, though, and it's really helpful to know why we keep doing N-1.
Okay.
Any other questions?
Thank you for explaining everything. It helps.
Oh, you're welcome. Glad to hear. Results are good. Okay. I'm just going to pause to see if anybody else has other questions. I'm going to check the chat room to see if anything came in here. And I think...
I'm sorry. I probably asked... I don't know. N-1 is always to decrease or increase?
Gotta make it smaller.
Decrease.
Yeah, it's always gonna bring it down.
Okay.
That's what happens when you've been looking at the formulas for too long. Then the migraine will set in about 30 minutes after the class ends. Any other questions? I just want to make sure everybody feels really rock solid on this before we get into the next part. Because if we rush it, it's not going to be as effective. Okay, I don't see anything coming in the chat.
Professor?
Yes.
So every time you give us a question that says calculate the variance, we're going to do the same steps we did in the question before, correct?
Yep, exactly.
Then X bar that with the average and that, okay.
Now, if you want to, Isabel, you can use the shortcut formula. I just don't teach that one because usually people blunder it on the test.
Okay.
Otherwise, everything you said is exactly correct. And I know a lot of you are going to take all the numbers and throw them into an internet website that can calculate standard deviation too. They're out there, believe me. And I know a lot of you will probably try to do that on the test too. Just probably worth mentioning, I am going to ask you a whole bunch of questions conceptually about the variance and the standard deviation on the exam, because I know many of you are just going to use an internet website to do the calculations where they just run the formula automatically. So the conceptual questions are there just to make sure you still understand what the calculations are, or like how do you interpret them. And really good examples of what the questions would be like would be the ones that we opened the discussion with today.
Okay, but it's always going to be the same setup we did before. I don't know the shortcut, so I'm not going to do the shortcut. I'll stick to what you taught me. So,
and you'll fly real high like that too.
Okay.
That'll get you full credit on all the questions.
All right, thank you.
Okay.
Sorry, just with like the conceptual questions in the textbook, I noticed like they were going over like K numbers and like, you know, the skewed graphs. Like, should we be taking notes on all that, like things that we haven't necessarily covered yet?
Can you tell me what page you're talking about, just so I know exactly what you mean?
I don't remember exactly what, I was just, you know, looking through it, like the boxes that were circled.
If you saw K, it's probably Chebyshev's theorem that you were looking at.
Yeah.
That's right after this. That's where we're going to go next.
Oh, okay.
The things that you can totally disregard, variance and standard deviation for group data is completely crossed out in the book. That's one that we're not even going to talk about. Coefficient of variance, we mentioned briefly in the last class to cross out too. We're not going to discuss any of that.
Okay.
Okay, so I'm going to roll us into the next section. We got just about enough time for it. And I'm just going to take a second to check in with everybody because in the classroom, I can see when people are just like on overload. So in the chat window, just send me a message. Let me know like if you're good, thumbs up, you're understanding things, or you feel like you're totally on overload with variance and standard deviation. Okay, looking good. All right, looks like people are okay, letting it soak in, but good. Thank you, Aaron. All right, so what we'll do is we're going to get into our very next theorem here. I'm going to turn this on. Do I have any Russian speakers in the class? Okay, if this is actually a Russian guy that made this theorem, and if you saw that, how would you pronounce it?
Chebyshев.
That's what I would say too. It's actually the Chebysheva theorem. And if you think that was a mouthful, his first name was Pafanudy. So it's the Pafanudy-Chebysheva theorem. And what did it say? So the Chebyshev theorem, this is what it said. Well, the Chebyshev theorem is pretty cool because it works on any data set. Like it doesn't matter if it's skewed left, if it's skewed right, whatever it is, it's always still going to work. And the only thing that you need to know to work the Chebyshev theorem is going to be the average and the standard deviation. So that being said, when you guys get on the exam, the Chebyshev theorem is basically going to give you a way to estimate how much data is around an average. There's going to be another theorem that sounds a lot like the Chebyshev theorem. We're going to talk about it, definitely not today, on Tuesday, most likely. It's called the empirical rule. The two of them sound very, 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 very close to each other in terms of what they're trying to do. And I see a lot of people that get confused on the test because they can't remember which one to use at what time. So how do you figure that out? And the answer that'll save the whole day, if you're going to do the Chebyshev theorem, it has to use either the words at least or minimum percentage. And that you like get that tattooed on your forehead. If you get stuck on a test, just run into the bathroom, look at the mirror. I see people all the time at the test, they're sitting there literally doing that, and it's because they forgot the key words, and it's going to be probably a 20-pointer question because it's a substantial computation to go through. And if you run down the wrong road, you're not going to be happy when you get the grade back. But if you remember the 2 words, then you're going to be just fine. You'll be right where you need to be. Okay, so Chebyshev theorem says what we can do is we're going to take our sample average and we're going to add and subtract 2 standard deviations for that sample average. And what that's going to do is that's going to leave us with a high number and a low number. And between those 2 numbers, we're going to end up with at least 75% of the numbers in the data set. If we went more standard deviations above and below, do you think we would capture more of the data or less of the data? Like, would that percentage go up or would it go down? And let's see.
Up.
Okay, I heard somebody say it would go up, and you're exactly correct because we're going a further distance away from the average. And I have to move some stuff out of the way on the screen because now I can't see anything. Bring this back. Okay, so we would get exactly 89%. Well, whoops, sorry, I misspoke. We'd get at least 89% of the data in the data set if we were to do that. So what we're going to talk about in the next class is what's the theorem that you end up using? Like, how's the theorem work? How's the formula work to get all through that stuff? And let me see, somehow I lost everybody's picture. Okay, that's better. Now I got it back. The formula looks pretty intensive. I'll just flash it on the screen for a second. This is what it starts to look like getting through all of it. And we're not going to be able to make all that happen in 10 minutes. All we're going to do is probably create a whole bunch of confusion. So what we'll do is we'll park it at the introduction here. And for the homework exercises, there's a whole big thing in the book circled of Chebyshev. Don't worry about that right now. We'll come back. We're going to do a full-blown explanation of the Chebyshev theorem on the Tuesday's class. And then you'll be able to do those extra homework exercises. I think there's something like 8 of them circled. Each one will probably take you at first about 20 minutes to get through. And we're in a good position right now just to stop at the introduction of the theorem, I think. I'm seeing the clock, it's 4:20. We're supposed to go until 4:30, and we're not going to rush this because it's kind of complex theorem. So for the homework for this evening, what I want you all to do is try to redo as many of those questions on variance and standard deviation as you can, but without looking at your notes. See if you can calculate it without the formula, and then that'll really help you make sure that you're rooted down in there really well. When we come back in on next week, then we'll talk about Chebyshev theorem, we'll talk about the empirical rule, and we'll be in much better footing to continue. Anybody have any questions on anything so far? Okay, I'll stay here for a couple minutes in case anybody does have a question that they thought of. Otherwise, have a terrific afternoon, have a great weekend, and we'll pick back up on Tuesday with the formula and a couple examples of the Chebyshev's theorem.
Thank you.
Great weekend.
Pleasure to be with everyone.
Good weekend, Professor.
Thank you. Have a great weekend.
Thank you.
Have a good weekend.
You all too.
Bye.
Have a great afternoon.
Thank you.
Professor.
Hi, Moshe. How are we today?
Good. How are you?
I am very well. Tada. Did I say that right?
Saying it perfect. Yes.
All right. Shalom Aleichem. Oh, no. Shalom. That's what I'm supposed to say.
Shalom. Shalom. Shalom.
Is that what you say back? Shalom, shalom?
Shalom is once, and shalom, shalom is like the answer. Yeah.
All
You
right.
repeat it
Excellent.
twice.
Thank you. How can I help?
Question. So the Chebyshev theorem, this is the X bar, correct?
Yes. This is your sample average, your X bar.
So sample average, if you add 2 standard deviations or reduce 2 standard deviations?
Yes. In the question, they're going to have to give you a standard deviation and an average. The thing we don't know right now, Moshe, is why are we using 2 in our formula? And that has to do with the percentage of data that they're after in the question. And that's the part that it's going to take us a lot more than 10 minutes to get through. We have to do like a whole bunch of algebra and stuff to make it bubble to the surface.
Sounds good. And the Chebyshev is either 2 or 3 or always 2?
Oh, great question. It could be 2, 3, it could be 2.5, 4. It could be, it's going to change according to the percentage that they're after. Like if they want to know between which two numbers we're going to get 83% of our data, at least 83%, then you're going to get something like 2.49. And that's something we'll get more into detail on Tuesdays, like how to account for any given percentage.
Right. It does ring a bell. So basically, I will always be asked to apply the Chebyshev on a certain either 2 or 3 or 2.5 or whatever it is.
Yes, you're usually not going to know what the K value is. Most of the time, you're going to have to do algebra to figure it out. And it's one of those things where it's going to probably take you 8 times to practice it to really get it to make sense. The first time through, people usually just kind of give me the deer in the headlights look. It's going to take probably like a good half hour, a good 45 minutes of the homeworks before it starts to make sense.
Mm-hmm. Now, just a quick question. You mentioned on the, what was it, on the sample?
Sample variance, sample standard deviation?
On the sample standard variation, you organized the numbers in order. It won't always be organized, correct? Because when you pick a sample.
Okay, I see what you mean. You mean in cases like, let me see if I can get a good example, like these? That's not
right.
even...
For example, so the 100 and 455, you do have a great variance.
Yeah, that's very true, Moshe. It's going to be jumbled up. The numbers will be all scrambled. And when we were doing our opening example, let me see if I could creep all the way back to it. Yeah, this is perfect right here. We had everything all laid out in least to greatest order. And that was because we wanted to see what it looks like if you have a lot of dispersion in your data set, like when it's really spread out versus when it's hugging the average. And we would just never really be able to see that if we had the data sets looking like we just saw before, like this, because you can't see any aspect of dispersion very easily. You just see basically numbers dumped on the screen. I think that's Isabel's been standing by with a few questions. Moshe, I'll come back to you if you still have more.
I'm only here, Professor, to hear his questions, to see. Yeah, right now I have no question. I just like to hear other people's questions.
For sure. Same thing happens to me all the time.
Yeah, I can answer one of my questions or any doubts or stuff. I'm just here to listen.
Okay.
Yeah, that's basically it. So no, just in this example, like on the screen, the 103, 5, and 455, that would be closer to a population data set.
Right, a setup. And what I'm actually going to do, I'm going to pause the recording so that the YouTube video doesn't have our questions in it. You want to keep on going. I think we also have somebody else that's still with us too, but I don't see the name. If anybody else has questions, feel free to just speak out right away. Moshe, you were correct. It's showing you if the data was just dumped out from a population, what it would look like.
Right. But it's still a sample.
Say again?
It is a sample.
Yes. In fact, the only data sets you guys are going to work with when you have to calculate stuff ever will be a sample on test 1. If you use the symbol for population, don't worry, I'm not going to take off any points. And when we get to chapter 6 and 7 and 8, that'll be different because it means you're telling me like 2 totally different things. But for test 1, we just want to start to learn the symbols, but you're not going to lose points if you use like a population average symbol when you should have used an X bar or something like that.
Sounds good. All right, that answers that. So thanks a lot.
Thank you, Professor. Have a great weekend.
You're welcome. Isabel, what's your last name?
Rodriguez.
I thought I saw a Spanish name. Do you speak Spanish?
Yeah, I have a very Spanish name.
Where did you learn to speak Spanish, Isabel?
I'm Dominican.
Verdad.
De verdad. Oh my God. Yeah. Sorry. I'm Dominican. Why? What nationality do you think I was?
Oh, I didn't even know. In fact, I can see your photograph about this big on the screen.
Oh, okay. I get African American a lot. That's why I thought you thought I was black.
No, I can see about 2 inches of you and 2 inches of motion too on the screen. Yo fui Dominican Republic, pero solamente una vez.
Okay.
Just once.
I think I heard you speaking Spanish the last time, and I think you do very well.
I think you're too kind.
No, for real. You're doing very well.
I used to live in Puerto Rico, and at one time I took a trip over to Dominican Republic, and I thought, yeah, I'm gonna practice out my Spanish, and I couldn't understand a word anybody said. They couldn't understand anything. I just gave up.
You speak very fast, so you speak like 100 miles per hour. No, we really do. We speak very fast.
But Puerto Rico is probably the worst place to learn Spanish because it's more of a pidgin Spanish. Like you would probably say buenos dias, we would say buen dia.
Buen dia, yeah.
And it's like if I were to go to Madrid, I would not understand a single thing anybody said.
Yeah, me neither, even Italians, because I work at a hospital and like I try to speak Spanish to some Italians and they're like, no. But it's
drunk or something.
It's some Spanish in there though. I feel like they're all diverse, our Spanish.
The best solution is just to learn Hebrew instead, right, Moshe?
Well, it works for me at least.
Something that you two might enjoy. I know it's obviously hard to do it now, but have you either one of you ever wanted to do study abroad?
Study abroad?
No, I don't think so.
It is interesting, very, but
yeah, not very interesting.
I'm already abroad.
Bergen has a lot of study abroad programs, and some of the schools close to us that people transfer to from here, you could literally go to Kabul if you wanted and do a study abroad there. And you get credits for it. And if you ever want to go to a graduate program, it looks really good on an application.
Why? Because of the diversity, you know, the different culture, getting to know different people and stuff?
Yeah, basically the reason why is it shows that you're really willing to get out and explore the world, and they're looking for people that want to get out of their comfort zone, that can adapt really, really quickly. So if they see that you did like a year in Israel or a year in Dominican Republic, a year in Madrid, they look at you as somebody that would acclimate really well onto their campus. And if you think about it, like, did either one of you ever want to do graduate diploma?
I'm trying to get into the X-ray program now at Bergen. Honestly, I'll probably just go for a bachelor's or a master's in X-ray. I don't know.
Oh, got it, for sure. So master's degree in medical field. Moshe, how about you?
I am thinking of continuing to master's, yes.
Okay, so here's why I asked. When you guys apply to those programs, a great example, a lot of people like to go into the nursing program at Bergen because that's where they're getting most of their students from. Now, when you apply there, they're so competitive. Everybody has a 4.0 that's trying to get in. So can you differentiate yourself on grades anymore? It ain't gonna work because everybody's got like the 4.0 that's applying to graduate school, like a 3.6 and above, and you need something else that nobody has.
Yeah.
They love looking at study abroad programs and seeing different languages and things like that. So just a thought.
Yeah, that's smart. Yeah, that makes sense.
It helped me out a lot. When I was in college, I did a couple of them, and it made a big difference because you can put down that you're bilingual, you're trilingual, and you want to rack up all the points you can get when you send in the applications.
Yeah, makes sense. If not, I mean, now with work and everything, I would need to quit my job to do that.
So would I.
Yes. And so far, it is working out for me with the studying. So. But yeah, in the event that I get fired or something, it's definitely something to look into.
Yeah.
You said you wanted to do radiology, Isabel?
Yeah, I want to become an X-ray tech.
Okay. Did you ever think about medical school?
No, I don't know. I work in the hospital, and I'll be very honest, I work at Morristown Hospital. I do registration in the emergency room, and I am too emotional. I don't know. I'm very emotional. I'm very opinionated. I'll see myself getting too involved. I probably should be a social worker instead, because I'll, like, you know what I'm saying? Like, patients come in, start crying, they're crying. I don't know if
my comment to that would be, if medical school is something you really wanted to pursue, then I can give you more direction on how to get around those issues. If it's not something you want to pursue, keep going with your gut reaction.
Yeah, I think I want to stick to x-ray, or because like in the radiography field, x-ray is the main thing. Then you can just grow from CAT scan to mammography, you know, anything else you want to do.
Reason I asked was radiologists are the second paid highest salary physicians out there. And you were talking about that when you started.
Oh, okay, I see. Okay, I see. No. I want to stick into like the tech field. I can't see myself sitting down with 3 computers reading x-rays, you know?
Now, Mocha, how about you? What's your career goal?
The goal, if everything works out, I would continue to law.
Oh, nice. Wonderful.
Yeah.
Lawyer, Moshe?
Yeah.
Nice.
If you can do it, I don't know where you are with your schooling. There are many schools right now that are waiving requirements for LSAT because they can't get people into testing centers.
Mm-hmm.
So keep that on your radar, because that's been a big issue lately. A lot of the schools are getting rid of they're getting rid of the LSAT, they're getting rid of the GREs, the GMATs.
So schools, graduate schools.
Exactly correct. Yeah. You've got to do the LSAT if you want to go to law school, right?
Yep.
Yeah, a lot of them are speculating, you know, what do? We can't get people into the testing center, and they're starting to I shouldn't say get rid of, they're waiving some of those requirements in many places.
That's because of COVID.
Yeah, they just can't get people into testing centers.
Yeah, I'm still not at that level. I'm still in my in the beginning.
Well, say that's what happened to you anyway when you apply.
Probably when I will apply for graduate, COVID will already have the vaccine. So.
Well, that's an interesting one. Wow. I think it'll be probably 3 years before we get a vaccine.
I think so too. I feel like people just got to learn to live with it. When the flu came out in 1918, I'm pretty sure people were acting like they're acting now. You know, I don't know.
Well, I think if more people were smarter about social distancing, this would be over a lot faster. But you have like colleges where the police are busting parties of 400 people in the same room. Mm-hmm. And if we were a little wiser about how we handled ourselves, I think we would have been done with this 2 months ago.
Yeah. But it's not the flu season is coming up, and we wouldn't be able to tell if it's the regular flu or COVID now. It's gonna get bad. I think so again.
It's gonna be a while before we see each other in school again. That's for sure.
Yeah.
So I know you guys have part-time jobs and full-time jobs and other classes too. So I hope some of this was helpful, but at the same time, I'm not too overwhelming today. If there's any other questions that come up, feel free to get in touch with me, because the rest of the chapter, we're going to start to not speed up, but we know more, so we'll be able to do a lot more. And the formulas get a little bit more crazy as we get deeper into it. Okay. So use the weekend really well. If there's anything you need to catch up on in the earlier sections, use that opportunity. So when you're getting into the tail end of chapter 3 next week, you're right where you want to be situated when the exam comes up.
All right. Thank you so much, Professor. Have a great weekend, everyone.
Everyone. See you next time.
See you Tuesday.
Good night.
Good night.
Right, so this is Thursdays and Thursday. Okay, Tuesday and Thursday, so I don't have an issue. It's just the Jewish holidays are coming up, so I'm trying to make sure I don't miss any classes.
Oh, if that does happen, Moshe, it's not going to be like last semester. I think when we did it, last time I had you in the class, was that in the spring, I think?
Spring, yes.
Okay. Yeah. You're going to have 24 hours to send a test back. So hopefully that'll help a little bit. Otherwise, if you miss a class, you'll be able to access the recordings. So hopefully that will alleviate some more of the concern.
Yeah, the one I missed right after Labor Day.
Yeah.
Yeah, so I sat down on the recording. I was like totally confused. I sit at work and I'm like, okay, what do I have today? Is it a class day, a video day, Zoom? I got all mixed up.
It's happening.
But yeah, I did go over it.
Are you in other classes also, or just this one?
Yes, I'm taking 3 more.
Oh my gosh, which are the other 3 classes?
I'm taking political science, music, and music, political science, and business communications.
Are they they're all probably running remotely, right?
They're all remotely. I have 2 of them, which is actual Zoom, which I need to sit down for a class, and the other 2 are like, one is completely on your free time, and the other one you do need to watch a video within that day, but any time of the day.
I see. Are the remote classes working out well for you?
It's interesting. I always, like, when I first started the school, I thought that doing online schooling would be very difficult for me. So I always took the in-class and everything. Now that I had no choice and I had to experience it, it's not bad.
Oh, this is good to hear.
Yes, yes.
Keep taking as many classes as you can before they change it back then.
Yeah, this is the time to stack on.
Have a great afternoon, Moshe, and we'll see you next week.
You as well. Yep, thank you. Have a good day. Bye.
Goodbye.